Welcome to Device Squad, everybody, the podcast for the mobile enterprise from Propelics and an Exec company. We're going to do things a little differently this time around. I'm going to let my friend and fellow senior mobile strategist, Glenn Gruber, take over, and we're going to listen to his October Emerging Tech Council Roundtable interview with the amazing Dr. David Bray, Executive Director of the People-Centered Internet Coalition and former CIO of the FCC. They're going to talk about AI and machine learning in the enterprise, and it's just an amazing conversation. So let's just get right to it. Device Squad, fighting crimes against enterprise mobility worldwide. Bad UI, frustrating user experiences, poorly conceived mobile strategies, we defeat them all. This podcast series will cover all aspects of enterprise mobility, including strategy, development, design, testing, and more. My name is Steve Brickman. I'm a mobile strategist and UX architect with Propelics. First, a brief history of the company. Founded in 2011, Propelics is a mobile strategy consultancy helping enterprises worldwide devise true mobile strategies and develop world-class mobile applications across all industry verticals. Propelics clients include large companies like Amway, Bright Horizons, Bank of Montreal, Dubai Airports, Family Dollar, DLL, Cintas, Merck, and many more. Propelics' menu of services includes 8 different mobile kickstarts, covering everything from mobile strategy and road mapping to MCOE to UI UX design to mobile testing strategy, along with soup to nuts app design development and support. Additionally, Propelics offers 3 homegrown enterprise mobile products.
Welcome everyone to our October 2018 Emerging Technology Council Roundtable. Real special treat today, talking to Dr. David Bray. I'll give a fuller intro in a moment, but I've had a couple of conversations with David, and they've been fabulous, and I think that you'll enjoy today's conversation as well. After we speak with David, we'll just very quickly talk about a couple of upcoming events, but I just kind of wanted to go in, and for those of you who might be listening to this as a podcast, I just want to talk a little bit about the ETC. For those who might be listening and are interested in joining. So the Emerging Technology Council is a community of Fortune 1000 technologists and business people, all really trying to learn about how to leverage and bring emerging technologies into their organizations and move them forward, both from a company perspective, but also in terms of their own personal development. So we talk about different technologies such as IoT, machine learning, and AI, which we'll talk about a good bit today. Bots, wearables, AR, VR, anything and everything that's interesting. And of course, mobile technology, which is really, still to a large extent at the center of all of these different technologies. And so if you're not a member, please go to emergingtechcouncil.com and join. And if you are, please go to Slack and continue to post and comment and ask questions of one another. So today we're going to kind of run this as a fireside chat, but really, really excited for the conversation with David today. Let's get right into that. David is the Executive Director of the People-Centered Internet Coalition at peoplecentered.net and also President of hue-manity.org. He'll tell us a little bit about both of those organizations in a minute, but I just have to say that David's one of the most accomplished people that I've ever had the pleasure to get to meet in person and speak to. David has served a variety of leadership roles in very challenging environments. He's been part, and I'll just give a brief bio as introduction. He's including being part of the bioterrorism preparedness and response team from 2000 to 2005. He's had time on the ground in Afghanistan in 2009. And ever since 2017, I should probably also mention that for a number of years, he was the CIO for the FCC. And then since 2017, he served as an executive director and co-founder of the People-Centered Internet Coalition, which is focused on providing support and expertise for community-focused projects that measurably improve people's lives using the internet. He was also named a Young Global Leader by the World Economic Forum for 2016 to 21, and a Marshall Memorial Fellow. Business Insider also named him one of the 24 Americans who are changing the world. He's received the Global CIO Award twice, which is usually awarded to private sector Fortune 500 companies in 2015 and 17 for his transformational leadership in change adverse settings. He's received both the Arthur S. Fleming Award and the Roger W. Jones Award for executive leadership in 2013. In 2012, he became the executive director for the Bipartisan National Commission for Review of Research and Development Programs of the United States Intelligence Community, later receiving the National Intelligence Exceptional Achievement Medal. So David has a long period of time in technology, and he likes working in challenging situations. He began some of his work in technology at age 15 on computer simulations at a high energy physics facility investigating quarks and neutrinos, which I'm sure is of great interest to my daughter, who wants to be an astronomer maybe one day. And then he's also designed telemedicine interfaces and space-based forest fire forecasting prototypes for the Department of Defense. From 98 to 2000, he volunteered as a part-time crew with Habitat for Humanity in the Philippines, Honduras, Romania, and Nepal, while also working as a project manager with Yahoo and Microsoft partner firm. As I read his bio, I'm thinking he must have the most amazing "what I did on my summer vacation" essays. Lastly, a couple of things. He was also the IT chief for the Bioterrorism Preparedness and Response Program at the CDC during the response to 9/11 and the anthrax scares of 2001. And because he felt perhaps he wasn't accomplished enough in his life, he completed a PhD from Emory University's Guizetta Business School and 2 postdoctoral associate at MIT and Harvard in 2008. And he was chosen to be an Eisenhower Fellow and work with leaders in Taiwan and Australia on multi-sector cyber strategies for the Internet of Everything. So that took a long time to do the introduction. That's only because, like I said, he's one of the most accomplished people I've ever met. Really glad to have him on the podcast. I think that we should all be, all have a lot that we can learn from him today. I would like to say, David, that it's nice to have a fellow Emory Eagle in the room.
Yes, indeed.
I know you got your PhD. I only got my BBA. It's definitely a first, and unfortunately, it's probably one of the few things that we have in common. You're an actual super genius. I'm more like the Wile E. Coyote type, but we'll keep going.
All of us actually, we all get up each day. We all try to do the best we can in our roles, and so that was a very humbling introduction, Glenn, and I appreciate you doing it. It also means that I just got to bring it to the conversation today because you just set that bar so high. So I want to first and foremost thank you and Al and everyone for the chance to have this fun, interactive conversation today about our rapidly changing world.
All right, cool. So before we get into some of the conversations around AI and how it's going to impact businesses and organizations, and how do you bring that in, and what can it do for us? Maybe you could tell us a little bit about the 2 projects that you're working on right now, or 2 organizations. So maybe start by saying a little bit about the People-Centered Internet Coalition, which, by the way, you and Vint Cerf, one of the sort of founders of the internet, 2 amazing leaders. But can you tell us a little bit about exactly what it is and what you guys hope to achieve with it?
Sure. So I've known Vint Cerf for, I guess it's now approaching 7, going on 8 years now. And I mean, obviously we all are, we're right now even having this conversation using it on the internet and with the World Wide Web. And as Vint likes to point out, he was part of the team that helped co-create the internet. Tim Berners-Lee was the web. And so they're always good to distinguish between the 2. But what we try to do with the People-Centered Internet is try to address the concern that there are 3rd order, 4th order effects that were never foreseen in how the internet and TCP/IP are being used that need to be remedied to make sure that the internet remains a force for good. It can range from everything from concerns about the internet becoming a surveillance state in some countries, or restricting the ability of people to have freedom of speech. There's also concerns about how do we address misinformation or disinformation increasingly showing up online, and raising questions about, how do we discern what is actually real or what's going on. It rises from, I don't know if folks remember, actually 50 years ago, from December of this year, on December 9th, 50 years ago, Doug Engelbart, who's probably most well known because he was the inventor of the mouse, but he did several other things too. He gave what was called the mother of all demos back on December 9th, 50 years ago. And what he showed was interacting with the computer where you would click on things. It was literally a wooden hand-constructed mouse that he was using. The idea that you actually had files, versioning the files, that you could actually then type into a what you see, what you get editor, and as opposed to sort of interacting with machines in other ways. And so he showed a lot of the concepts that we now take for granted with modern computing. And Doug Engelbart also had a vision that technology could help bring together people into what he would call living learning communities. Now, that the machine could help us learn faster. It could address some of the sort of challenges we have as humans in terms of how we think, limits of our processing capabilities, and that it could actually be a way we could learn from each other in different communities. And what I would submit forward is how many of us feel like the internet is necessarily helping do that, versus where we now see, and this has only been fairly a recent thing in the last decade, that maybe the internet is actually polarizing groups, or actually alienating people, or making people only see the best things when they look online, and not realizing that all of us are humans, and that's actually causing a low self-esteem in some cases. And so really what we're trying to do is ensure the internet remains a force for good. We don't pretend to have all the answers, but by doing demonstration projects, we can learn and embody that living learning community, and ideally get other insights from other people as we move forward as well.
Well, that's some lofty goals, but definitely important work. So, and maybe let's also, if you could talk briefly about humanity.org.
Sure.
Because, and I'll just add in here that as someone who cherishes their online privacy, when we talked about this, it sounded really interesting. So,
sure. So, Humanity, and it's with a dash because apparently the full name was already taken. So it's hu.manity.org. There's also hu.manity.co. It's a combination of a for-profit startup, which is the CO side, and the nonprofit, which is the .org. And what we're trying to do is see if people can express in an immutable audit form on a distributed ledger what they want specifically done with their data. And it's tied to this idea that maybe what we need for the 21st century, yes, privacy is important, and maybe we even go further and actually say that if it's data about you, if it's your digital exhaust, then you should be able to treat it as if it's your own personal property and reach some agreement with whatever service is going to be using it. I see someone asked about blockchain or hyperledger. I intentionally did not use either of those words, because blockchain has some challenges with scaling. It's also a question of which blockchain you're talking about. Hyperledger is a little bit better, but even then, there are challenges, especially when you're doing proof of work, when you try to get to 2 million, 3 million, or 4 million people or beyond, with trying to synchronize across all those different people and do so in a timely fashion. And so the vision is, yes, something that is a hyperledger-like distributed ledger in immutable audit form. But we are not tying ourselves to specific technology. In fact, there is actually an R&D effort that is meant to try and get this so that we can scale beyond 4 million, 5 million. And essentially what happens is now, and instead of when you engage right now, you get a 30 or 40 page terms and conditions sheet when you download something from the web, and it's Boolean as to whether or not you accept or not. In the future, you could actually have a much more granular approach that says, look, I am willing to use your app and you can have access to some of my data as long as you agree to these terms. And it's actually sort of a bi-directional conversation. And Humanity would help sort of broker that conversation. Our first focus is actually on medical records. A lot of people may not realize that right now in the United States, there's this thing called HIPAA, Health Insurance Portability and Accountability Act. And it interprets, it says that as long as you remove personally identifiable information from a medical record, then you've taken care of privacy. Well, all of us, for the most part in the tech room, know that if you get enough data, even if it looks anonymous, you can begin to triangulate, and that which doesn't look like it has any personal identifiable information, you may eventually be able to figure out who it links to. In fact, there's already articles coming out about how we thought that DNA data was private, but if one of your family members or relatives have done a DNA test and identified themselves, odds are, even though you tried to stay private and you did a DNA test, they can probably figure out who you are. And so what we're trying to do is saying, you need to be able to have granular control about what's done with your medical record and be able to express that. And you can say, I want to have it shared at all, medical purposes, or I'm willing to have it shared because I support cancer research or Alzheimer's research, as long as you do appropriate steps to de-identify my data. Or I'm okay with you sharing it as long as you lop off my personal identifiable information, but I want some sort of reimbursement, because right now what people don't realize is medical records are being sold on average for about $470.
Yeah. So that, I mean, that kind of stuff is very interesting to me. I'm going to guess that Mark Zuckerberg is not on the board of humanity.org at this point, but I mean, it's definitely very a great interest to me. Yeah, this topic. I think also, some of the other things that we had talked about the other day were about how that being able to triangulate data, so that even if you strip away what a lot of people might consider to be PII style information, you can still start to figure out maybe who that individual is, and therefore their data is, in ways that just aren't obvious to most people.
Right. Oh, and exactly that. And that's why we're trying to say, the challenge with trying to fight for just privacy. Privacy is important, and we definitely want to fight for that. But as we now know, you can't ever really say something's been anonymized, especially if you get enough data. And of course, the internet has plenty of big data out there that can de-identify who you are, even if you did your steps to try and be anonymous. Right. And so that's where we think the way going forward, and we're looking at what's going on in Europe as well with General Data Protection Regulation, or GDPR, is to treat it instead of just privacy, it's also a matter of property. And if it's data about you, it should be your personal property, and you should have a locus of choice and consent as to what's done with it.
Yep, absolutely. Okay, so we, that kind of maybe takes us into the conversation, when you talked about there's big data and there's all this data out here, into AI. And I know that we've talked about this a couple of times at the ETC. You and I have obviously discussed it a few times, but just for maybe people newer to this conversation, can we just step back for a second and just talk about like what it is, and let's put aside the Skynet based fears of generalized AI and things of that nature. But can we talk about maybe just start about is AI like kind of one big thing? How is it different than machine learning or deep learning or neural networks? How is it even different than big data?
Sure.
Which we've talked about for years.
Right. So let me first do the history, and then let me give sort of how I sort of approach it in terms of how do these things all link together. So if you go back, after World War II, and even leading up to World War II and during World War II, there was this idea of being able to have machines help do tasks that humans were doing, specifically problem-solving tasks. And so there was an individual by the name of Herbert Simon, who ended up being a Nobel Prize winner. But interestingly enough, actually, his PhD was motivated because he had helped with local New York State government, and he had observed how people made administrative behavior decisions or administrative policy decisions. And he came to the conclusion that when you watch people make decisions, generally they only sort of go so far out of the realm of things they already know. They don't go over that horizon. And he basically identified this as what he would call optimizing. And it was just partly because he just mentally, if we try to explore the search space every time we try to do a new task, we would paralyze ourselves. And so throughout the day, and this is what part of becoming an expert is you are doing a search space, but you're doing a search space that is focused based on what your expertise says. And you can think about this in practical terms. Something's going wrong with say, a network connection, then you're applying your knowledge of networks, but you're not meaning to bring your your ideas about how cars work or something like that. You're bringing whatever domain of knowledge that is there. And so Herb Simon and later several others, Alan Newell and others, focused on what they would call sort of general problem solvers, which were meant to be initially mathematical algorithms that could later be fed into a machine that could help solve a general class of problems that were, how can I best optimize, say, the traveling salesman problem? You know, I've got a salesman, he's got to go all these different routes. What's the best way to do that? And so this class of what was called general solving problems was the first wave of AI. And it was very much the idea that you define your problem, you give the machine certain rules, and it'll figure out the best way to do that. Fast forward, that was the first wave of AI, and it sort of rose in the 50s and 60s. There was a lot of excitement, but it also hit some road barriers. One was just sheer computational speed. Machines just weren't able to process as fast as they are today. Also was limits in memory. And so a lot of the things that were envisioned in the 50s and 60s are only possible now with general problem solving algorithms. There was then a second wave of AI that came about in the 80s. It was late 70s and 80s, and these were things that were called expert systems. There are also things that were called decision support systems. And it was the idea that if you sort of, again, had sort of a how does an expert reach a decision as to whether or not you have cancer? Or how does an expert reach a decision as to whether or not you're having a heart attack or you're having a problem with your heart? You can actually teach the machine to be as good, if not better, than 95% of experts. A lot of these applications are also in the military. Decision support systems for how am I going to handle logistics for deploying Navy fleets, for example, or things like that. And so that was the second wave. But like the first wave, it had a lot of promise, and then it just sort of, and exactly, I saw someone mention Whopper. Yeah, if you saw that War Games, Whopper was exactly that. How best to play the game. Would you like to play a game of chess? So that's an example there too. It hit a wall in the 90s, and so people became a little disillusioned with AI after the second wave. And so now we're in the third wave of AI, which is coming about partly because a lot of the things that people envisioned with the first and second wave are now possible with cloud computing technologies. In fact, I like to say cloud is the appetizer that you must have in order to think about actually doing AI at its scale. Now, it could be private cloud, it could be public cloud, it could be hybrid, doesn't matter. But unless you have the elasticity, both for the computational cycles and the data, you're really not going to be able to do everything that you want with artificial intelligence. And this third wave of AI, it is, in some respects, it's taking everything that was promised in the first and second. So some of it's rules-based, some of it is expertise-based. But there's a third wave that came about that was basically, it said, well, let's say we don't even have to try and make all the rules. Let's just say we teach the machine like we teach a 5-year-old. And what do I mean by that? You know, we don't teach children to speak saying, okay, here's a noun, here's a verb, here's an object, and they've got to be linked together this way, and if you don't, then it's awkward or something like that. You don't do that. You basically just expose a child to enough language, and eventually they say something like, I'm going to run to school today. And when you say and ask them, why did you say it that way versus something else like, to school today I'm going to run, which to our ears sounds awkward, the child is going to say, it's just because I never heard it said that way before, that they heard it other ways, but not that way. And that's true for this third wave of AI, which is a lot of pattern recognition and a lot of learning as to what are either the more accurate patterns to solve some sort of feature or optimize some goal, or superior patterns relative to others in terms of achieving some outcome. And so when you ask a machine, why did you solve it this certain way when you do it this way? Essentially, it's basically the machine just says that's how I see it. I see there was a question that asked about is this in heuristics or something else? It could be heuristics, but it actually could just be simple as I'm feeding data as to when does the stock market go up and when does the stock market go down, and what other activities are happening that same day. And in some cases, the machine may actually find a pattern that's spurious. For example, it might find that the stock market tends to go up more on sunny days versus non-sunny days. And while there shouldn't be any reason for that, since it's a global stock market and the sun's not limited to any one place, the machine may find a pattern. And so that's actually one of the limits that people need to be cautious of is As we embrace this third wave of AI, I think we'll certainly find limits to it. And one of it might just be, with enough data, you will find patterns. Whether or not those patterns are meaningful or statistically significant or things you can count on is unclear. Now, you ask about how does this differ from big data? Here's what I would ask people to think about is imagine a triangle, and it's actually an inverted triangle, so the point's at the bottom. On the first part of the triangle at the top left, you've got sensors. These are sensors from the Internet of Things. They're collecting data, but also Internet of Things devices don't just collect data, they can also do things. They can be articulators, they can move things, they can take action, they can be robots, or they could even be swarms of drones or something like that. So these are sort of like the eyes, ears, and in some cases even arms. You move to the right of the top of the triangle, and that other side of the triangle are the data streams that are being collected or produced or directing those devices. So again, the IoT is collecting devices, information on traffic, collecting data on weather, could be collecting data on queries being asked to an Alexa or a Siri. And these are massive streams of data, but it could also be guiding these swarms. And then finally, the very bottom point of this triangle is really when the algorithms, and there are different types of algorithms. It could be machine learning, which is the example where you're training the machine to do a task, and you've defined what the right task looks like, and the machine is going to try and achieve it. If it doesn't, it tries again and tries again until eventually it solves it. But it can also be neural networks that are trying to figure out how to optimize something. But regardless of it, it's this interesting triangle that involves the sensors having data streams to the algorithms, and then the algorithms then going back to the data streams and telling the sensors to either collect more data or do something. That, to me, is the overall picture of where we're going and how AI fits into that sort of overall perspective of big data and the Internet of Things.
So is big data then is big data then the kind of the top right part of that triangle where that's all the information coming in, where you've got this massive amount of data that you now have available to you, and therefore now there are new questions to answer, and that and is it that machine learning has the provides us the ability to get answers that we couldn't otherwise derive even had we had all that data?
Right. Yeah. So yeah, exactly that. So this third wave of AI relies a lot on large amounts of data that just up until now were not possibly collectible, and that the machine can become more accurate simply because you have so much data. Let me give you an example. So Google Translate, about 6 or 7 years ago, was trying to do a statistics-based approach to when you use this foreign noun next to this foreign verb, next to this foreign adjective, this is the overall phrase you're trying to say. And that was accurate to a degree. But what they found they had, and where you began to see Google Translate get really exceptionally good at, was when they actually went away from using a statistics-based approach, and it just basically exposed the machine to lots of conversations. And it just turned out that without having to come up with the statistics, and I see some people talking about decision trees or heuristics, I mean, there was no explicit programming of the machine. It just simply said, here's what people are saying in French, here's what they mean in English. I'm just going to show you enough data, and so that when you encounter something that somebody says in French that's new, odds are you'll get it right. And that's when you started to see Google Translate get really spookily, on certain language pairings, accurate, because it could do idioms, it could do jokes, it could do implied tones, which is really hard to do. But what was even more interesting is, so you had to train it on language pairs, so French, English, Spanish, English, Russian, English, whatever. If you then approached a new language pairing, such as, I don't know, English Portuguese, that you had not trained the machine on, but you had already done English once and you'd already done, say, Portuguese Italian, the machine would actually already be more than 50% accurate without any new training. And that's where the scientists were just like, wait, what's going on here? And as near as we can tell, and this is again an example of what's called emergent behavior that was not predicted, as the machine was learning these language pairs, it was actually creating its own version of digital Esperanto that was an intermediate language between these other languages, which made it even more ready to learn new languages in the future that had never been exposed to. And maybe that's something similar that happens in the wiring of the human brain, like where they say if you've learned one or two languages, if you've done more than two languages, it's a lot easier to learn a third or a fourth. But it was one of those things that the scientists never predicted. And sure enough, after you did it, it was this emergent behavior that was like, oh. So yeah, it's only possible with large data that you can actually have some of these very interesting gains. And that's only possible now because we have cloud computing and we have these devices that are collecting it.
Okay, so and these emergent behaviors that didn't expect, that's why people always think that the computers are going to kill us one day.
Right, and that's Hollywood. I mean, Hollywood is never going to show you a movie where, I mean, let's face it. If an AI ever does go amok, worst comes to worst, you do an EMP blast that kills all electronics in the area and we rebuild from there. To me, it's not the existential threat that some claim it to be. I would be much more worried about biology. Now, of course, I came from the bioterrorism program, and by the way, I like to caveat it was the bioterrorism preparedness and stopping bioterrorism, countering bioterrorism, not doing bioterrorism. But I raise that because to me, whereas if a machine does something wrong, you can reboot it, or worse comes to worse, you do a wipe of some form. It's a lot harder to do a reboot or a wipe if something goes wrong there.
Yeah, well, actually, the EMP thing is something that's good because we don't have the Avengers, but it's you had to save us from Ultron. But somehow you had Bruce Banner and Tony Stark, and neither of them thought of the EMP. But so that's small little error. So anyway, okay. So natural language processing is one thing that we talk about in terms of what AI is doing well. Vision and recognition is another, but beyond those things that we see as primarily as consumers, what else is really working well today with machine learning and AI? Like, what type of tasks is it good at?
Yeah. Right. So it's apparently getting really good, and in some cases actually better than the average person at identifying emotions on faces. Machines are better at that. And it's just being exposed to millions upon millions of faces, and it just learns, whereas most of us don't sit the time and learn that. So it's better at identifying emotions than the average person on faces. It's actually developed its own encryption language, where actually they basically just said, your goal is to come up with an encryption language, do it on your own. This one actually had an interesting, there was one effort at this where they actually had to pull the plug on it because the machine started doing a form of communication that the researchers didn't actually know what it was doing. They had been able to track it to a certain point in time, and then it started doing communication back and forth, and they weren't exactly sure what it was. It was different machines talking to each other, and they opted to pull the plug because, again, it was an emergent behavior, but it was one that they could not follow. And while, again, it's probably highly unlikely that machines would eventually say, hey, wait, there's this thing called TCP/IP. Oh, we can go off on TCP/IP and go to another machine. They wanted to be safe and avoid what would have been the biological equivalent of contamination of machines beyond the original machine that was trying to work on the conversation. And so, yeah, machine-to-machine talk was quite an interesting example. There was another example, Carnegie Mellon, where they got some of the best poker players, and they had it play against the machine. And the machine had someone asked about decision trees. So the old way of doing AI, whether it was the era of Herb Simon with the first wave or the second wave with expert systems, would have been to explicitly teach the machine the rules of chess or teach the rules of poker and how to play. Now, we know poker's different than chess because it's not just about the hand you're played, it's also the bluffs that you do, and it's bluffs over multiple games. And so that's a little bit more tricky. But in this effort with Carnegie Mellon, they did no programming of the machine beforehand. They just basically said your goal is to win at poker. And you will begin to interact with the humans. And you can imagine for the first several weeks, the humans were beating the machine over and over again. It was about 8 or 9 weeks, I think, in that the machine started winning a few hands. And it was only another 2 or 3 weeks later that it was beating several of the top poker players. In fact, in the end, I think it won everything. And that's, again, it's just, you just expose it to enough. And that's one of the things that we need to make sure we don't miss is, because this is exponentially gaining, it'll look initially like nothing's improving. It looks like it's very marginal. It looks like, what's the point of it? It's not going anywhere. And then all of a sudden you get on that interesting hockey stick, that ski slope of that exponential curve, and all of a sudden it gets really, 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 really good. And so when we are trying to think linear and say, oh, well, if we follow that linear projection, it's not going to be good for another 20 or 30 years, we miss the fact that it's an exponential curve, and all of a sudden we could be on that hockey stick. And whereas for the last 8 weeks prior, the machine was losing, then all of a sudden it's winning a bit this week. And we think, well, maybe it's going to continue like that for another 2 months. Whereas within 2 weeks, it's now winning against everybody, which means now the machines can effectively bluff, which does raise interesting questions about future car sales. Do you need to have your own AI app that reads the face of your car salesman and makes better offers than you would if you did it by yourself?
That's funny.
No, and then think about it seriously. I mean, if this is not happening for diplomacy efforts, I think it should happen for diplomacy efforts, because you need to have a machine that's reading the faces and listening to the tone and reading the language of the diplomatic negotiations, and then making suggestions as to what the human diplomat should do.
All right, that's starting to make me nervous. Okay,
so
yeah.
but so the interesting thing here is, because a lot of people talk about, are the machines going to replace us? Are they going to enslave us? I'm like, no. A machine is simply optimizing a goal. And while technically you could give a machine a goal of achieve world domination, that's such a broad goal, it probably won't be able to do that. I mean, right now, that's not what people call artificial generalized intelligence. But you can give a machine of win at this negotiation, or win at playing this game, or achieve the best outcome for this financial transaction, and it can optimize to that. Now, if it makes you feel better, machines can't, I don't know of any programming language at the moment that allows the machine to change its own ultimate goal. It can change some of the sub goals, but it really is, it is about thinking about sort of the machine will optimize to the goal the humans gave the machine. And it's then also thinking about how we can pair humans, because we have things that we do great. We're really great in novel situations. We're really great at things that don't match things we've seen before. We're really great at sort of probing the why. Right now, if you ask a lot of these machines why, they'll just say, that's what the data said. But they won't be able to tell you a reason why. But the machine is really good because it doesn't have to eat, it doesn't have to sleep, it doesn't have to go to bed. It can handle research shows we as humans can only do about 8 to 10 things in our mind at any given time before we lose count of the things we were supposed to remember. And clearly machines can do a whole lot more.
Yeah,
so and it's going to be pairing humans with machines. That's the future for at least the next decade.
Yeah, and that actually kind of, what you were just saying reminds me of something I heard from Benedict Evans from Andreessen Horowitz, where he said that, right now where AI is at, for certain tasks, it may not be smarter than a 5-year-old, a 10-year-old, a 15-year-old. So basically, AI is like an intern. But the difference is that because you can, because of what you were saying, that it didn't, it doesn't need to sleep or eat or anything like that. It's really like being able to spin up millions of interns immediately, to try and solve a problem and kind of work through some of the analysis that would otherwise take us much, much longer.
Right, exactly. And there's a wonderful video people haven't seen. I won't name the name of the car company, but you can probably guess who it is. They have footage of the car following another car, and the car in front of them eventually gets in a car accident. The car that's following actually stops to avoid the accident. But what's interesting is you hear the car ding prior to the car accident, and if you stop it at that footage and you ask anybody to take a look at it, nothing looks odd. It looks like a perfectly normal drive. You're far enough behind, everything like that. But what was actually happening was the machine, the AI, with the technology that was available, was not just scanning the car in front of you, but was also scanning the car in front of that and the car in front of that. And it could project that the car that the human driver could not see, that was in front of the other car, had not allowed enough distance to stop because the other car was stopping. And so that car was going to be rear-ended. It was then going to call the other car to rear-end it. And so it proactively stopped your car. And that's something that human beings can't do. I mean, as far as I know, we can't see through other cars at the moment. And even if we did, it would be kind of odd. And so it's about pairing what the machine does well with the things the human does well, so that you get a better outcome than any one of them by themselves.
Yep. So actually I'm going to kind of go a little bit out of order of how I was planning about this, but that does start to get into the interaction between humans and devices, machines, as it were, and talk about the impact of AI and jobs.
Mm-hmm.
So a lot. So you talked about that. Really, right now, it's going to be something that is an adjunct to what people do. And then a big part of what we have to do as technology leaders is not just, obviously building the algorithms that we want to do, but also figuring out what that balance is of how you present that information to the user, and what those interfaces look like, to really have, especially like your your comment earlier about having AI make suggestions in diplomatic negotiation. How do you surface that intelligence at the right time?
Right, and I think that's actually, we're increasingly going to need more research into a science of when is the right time to share information, when is the right to interrupt the human. In some respects, some of this is already starting to happen with doctors, where especially for radiology, in most cases now in hospitals, not only is the physician looking at the chest x-ray or the CAT scan or something like that, so is the machine. And there's actually, while it's not maybe an explicit consult between the machine and the doctor, there are some, the machine says it looks like this, the doctor might say, well, I think you're wrong, and here's why. And there's efforts, IBM Watson being one of them, but there's others too, that are trying to have the machine constantly read the medical literature, which is just growing so fast that no one human can read it and keep up with it all. So that if the doctor comes back and says, machine, I think you're wrong, the machine can say, okay, I understand, but you may not have seen this article that just came out 3 days ago in this journal that says, here's the differential diagnosis that you need to do per the most recent gold standard. And so it's an interesting intersection between the two. But you also think about it, it's not just the doctor interacting with the machine. It's actually, if that machine is a service, and it probably is, it's thousands of doctors around the world interacting with the machine and learning, and so they're teaching the machine and also learning from the machine. And there was actually a question that one of the folks asked about, is this also happening in the security standpoint? And it is. First, it's just trying to make sense of what are odd patterns, whether they be patterns that are happening in so many different locations that if a human looked at it, each one would seem innocuous, but tying them together, it's something that's very odd. Or things that are just happening so slow over a period of time, sort of that glacial by themselves, again, innocuous, but if you build up over a period of 6 to 9 months, now it's disconcerting. The machine can also do some correlation with that too. And ultimately where you're trying to go with all this is, there was actually a competition just last year. It was Defense Advanced Research Projects Agency, DARPA, had a competition to see if colleges could produce AIs that could identify flaws in code and identify a patch faster than human teams could. And it actually came in third relative to the human teams, which were first and second, and that was the first year. And if you remember, there was the grand challenge that was done about 10, maybe more than 10 years ago for driverless cars with DARPA as well, where the car really didn't get beyond about 100 feet. The first year it was done, but now, we've demonstrated autonomous cars can go back and forth across the coast to coast many times. I think that similar approach of let's see how the machines can improve and incentivize people to do that. We may look back and say, remember the 2017, 2018 periods where humans, for the most part, were trying to do patches and managing patches and always being overloaded with different vulnerabilities. And it was by the time 2021, 2022 came along that it really was the machine, not just applying known patches, but constantly scanning for unknown vulnerabilities and trying to come up with its own ways to fix it.
Yeah, and I think on the security side, that's a little bit of what, at least if you believe the commercials, what Microsoft said that they're doing with their Azure-based threat detection, platform. So,
yeah, it's definitely. I think, and I don't know specifically about that platform, so I won't comment about that. But I think there are some fairly simple things, if they're rote and repetitive actions, that lend themselves very easily to being done by AI today.
Yeah, and I also want to go back to the diagnosis example that you gave, with the doctor comparing their diagnosis versus what the CAT scan system comes back with or such. One of the other things that you and I talked about when we first spoke was about also how AI can remove bias out of the decision-making process. So it could be that I, as a physician, have seen, these presenting symptoms, a certain number of times, and it's kind of always come out to be, a certain diagnosis, and so you're almost predetermined to go down that path, and therefore you may overlook other data.
Right.
So, maybe you can talk a little bit about how, AI can, remove that personal bias. And even I think that we talked about not just on the medical side of things, but also determining who gets a loan and who gets denied, and things like that.
Right. Yeah. I mean, you're seeing people start to have conversations about how do we know what biases are present in the AI. They sometimes talk about what are programmed into the AI, and I think these are really important conversations to have. But I often like to say, at the same time, let's be aware we don't know what biases are present in human decision making either, especially if it's in groups of teams. And when you approach people and say, "Are you aware you're biased?" Most people will say, "No, I'm not biased," or I try to be open-minded. But there's two really good examples. The first is I'd actually ask everybody on this call, or the people that are listening in later, go ahead and cross your arms the way you normally would. So cross your arms, and now try to cross them the other way. And I bet if you try to cross it the other way, that feels weird. That feels odd. And so you have a mental way that you cross your arms that if I ask you to do it differently, will feel weird. And that's just one small example. There's another example of where you take data on chief financial officers and their salaries, and you plot it relative to their height, and you'll find a very strong correlation that the taller you are, the more your salary increases. But there really aren't any good reasons why someone's salary should be paid more the taller they are as a chief financial officer. I mean, maybe as a basketball player, yes, but not a chief financial officer. And so we humans have biases in how we see the world, and it affects our decision making, and it affects the things we ascribe value to as well. And this is, in some respects, those are some examples of bias that don't necessarily serve a purpose. But there's also, becoming an expert means you do learn to see the world in a certain way. You have certain heuristics. So for example, Frank Lloyd Wright was an amazing architect, but he was an awful engineer, and his buildings are now falling apart. It would have been great to have Frank Lloyd Wright paired with a great engineer, paired with a great nature conservationist while you're at it, and his buildings would have lasted much longer. And so really what we need to think about is AI could, in some respects, hold up a mirror to our biases. And actually, I'd love to see something that says, you can imagine for HR departments, do you know that the last 20 offers that you've made on different jobs were to people that match these certain characteristics? Now, HR might look at it and say, okay, that makes sense. They're computer scientists. That's what we're looking for. Or they went to these schools. I guess that's what we're looking for. But they may also say, well, maybe we're looking at only these types of schools when we should look at other schools as well. Or maybe we should look at things beyond just computer science. Let me give you one example as to where what's called the adjacency effect can be valuable. In the United States, when we were trying to respond to the Ebola outbreak, there's suits that are worn. Those hazmat suits get extremely hot really fast. They're very bulky. And usually people can only wear them for about 20 to 30 minutes before they're just dripping with sweat and they have to exit, which is not really good if you're trying to respond to an Ebola outbreak and you have to get out of your suit every 20 to 30 minutes. So they were looking for better ways to design the suits. And it turned out that the person that had the genius idea actually was a wedding dress designer. Which would not have shown up if you were looking only for people that had expertise in, say, public health, or only had expertise in, manufacturing of hazmat suits. But there was this sort of expanding that surface space, which is, again, what Herb Simon pointed out that humans don't often do, that actually led to a better outcome. I think AI can help you say, look, your decisions seem to be clustered in this area, and maybe that's good for the most time when things are going normal. But maybe you need to expand because something else novel has now shown up, or the world has changed, and you need to look further. And it may also hold up a mirror and say, are you comfortable with the fact that you tend to have these biases when you're making these types of decisions? Do they fit with what you want as an organization, or do you want to change them? And so while I do think it's good that we should be asking questions about AI being biased, in fact, unfortunately, there are some really bad examples already out there where AI is biased. This can help. This can also help at least hold a mirror to human beings to make us better as well.
But over time, shouldn't any bias that was perhaps originally put into the algorithm or the design weed itself out via the repeated decisioning that goes on to start to see that, hey, I thought that this would be the right these characteristics would point me to a good outcome, but I'm noticing that actually they're pointing us to a bad outcome. I should change either the weightings of those factors or look at different factors.
So yes and no. If it's something that's hurting the company, then generally the machine and or the humans that are working together will make adjustments. But let's say it's not really hurting the company, but it's not really getting the massive gains or benefits that the company deserves either. And this is where I think you have sort of a stagflation effect, where it's not harmful enough for a corrective action to kick in, either on the human or the machine, but it's also a suboptimal state. And so, for example, you might be focusing on a certain market segment, and that market segment might be good enough that you're making your goals and you're doing your returns, but you're not seeing 10x growth. You're only seeing maybe 1.5x growth. And so the machine can expand that search space and says, well, look, I know you're focusing on this market, but maybe if you focus on this other market over here, which is just taking off, you may see better things that can occur. And the other thing to also keep in mind, and I see some people that are talking about, thinking about gender equality in the workplace or things that remove the gender bias, garbage in, garbage out, which is a computer science model. If we take past decisions that themselves were flawed and we feed it to the machine, this can cause the machine to repeat those same biased decisions. And let me put in a concrete example. I don't know if people have used a thing called Face App. It's an app that came out about 2.5 years ago. I don't know if it's still if you can still download it or not, but basically what it did at the time was it allowed you to take a photo of your face, it would scan your biometrics and produce a cartoon character of your face. Now, before you go off and do this, I recommend reading the terms and conditions. It's based in St. Petersburg, Russia. Decide for yourself if you feel comfortable sending your biometrics to St. Petersburg, Russia. But regardless of that, when you hit the beautify button on your cartoon character's face, unfortunately for a while it made everybody's face lighter in complexion, which is wrong. That's an anathema and that's not right. But if you look at it, this was built in St. Petersburg, Russia, where the diversity of people that were used to train the system to translate their actual faces into cartoon characters was less than diverse. The machine itself reached a spurious correlation that was somehow beautiful. We've also seen this happen on Google, which is there are certain things when you try and do the autocomplete right now, and you try to ascribe pronouns to certain job descriptions, Google, based on what it's found on the web, will ascribe pronouns to certain jobs that are either masculine or feminine, which in reality, either gender can do, but it has just based it off what it found on the web, which itself was biased. And so I think we need to be very careful about using historical data or data that we've not questioned about its representativeness or diversity in feeding the machine, because that itself will produce a suboptimal outcome. Another example that's a bit of a problem already, well, it's not just a bit of a problem, it's a significant problem. For identifying people's faces by facial identity, there are some algorithms that come from certain countries that cannot identify people that are African American. And so that's a problem as well.
Huh. That's odd that would be something that they couldn't figure out. That's weird.
Well, it's basically you need to have, and it raises a very interesting question. I mean, I'm all for, and I'm not saying we should not have data privacy in the United States, but let's say there's a very large country of more than 1 billion people, where they maybe don't have the same concerns of data privacy. They are training the algorithm on their people, and they have 1 billion people that are training it against. And it's getting, so in some respects, they have an edge and they have an advantage at facial identification that the United States doesn't, just because they have that data set.
Let's try and maybe, yeah, especially because of the group that we have here, where everyone works at very large companies, and we're trying to bring things like AI into the enterprise. So let's talk about that. Maybe at a little bit more of a concrete level. How do you think that organizations should look to bring AI into the enterprise? And I think about this kind of on two different levels. One is maybe how do we identify what are the right kinds of characteristics or attributes of a good use case? Because the thing that I see all too often, and not just with AI, but with lots of these new shiny object style technologies, is people wanting to use the new tool because it's cool and it'll probably help my resume if I'm part of something that we do here, but it's not really required. So if you're going to do just like basic web analytics, like you probably don't need machine learning for that. So maybe we can talk a little bit about how to start to identify good use cases.
Sure. And actually, if I could, right before I jump to that one, let me even talk about how to even know if your organization is ready to even consider doing AI. And I think the first step would be, do you know what the valuable data is in your organization and which different units have it? And I'm not just talking about the files or the databases. I'm like the actual, like we have data on our customers over here. We have data on our supply chains over here. If you don't know where your data is and which data is the most valuable, you've got a lot of problems, but you won't be able to necessarily do AI well. So that would be almost the first 101 step. The second would then be assessing, do I have the elasticity? Have I gone to cloud in some form? And do I have the ability to bring in AI as a service? Because you really don't want to program your own AI, partly because you're not really going to be programming. I mean, these algorithms are pretty much known. There's a thing called OpenAI, but there's several others. It really is the uniqueness of the data used to train the algorithms that'll give you that unique advantage. And so that's why you don't really want to be programming it. You want to have someone else that maintains whatever the training is, but you want your own unique secret sauce, whether you're doing it in your private cloud or your public cloud, to be what you brought to bear. The other thing to think about, though, then is when you are looking for where does it make sense, I would recommend 3 areas. First, what are the things that are rote and repetitive that are done over and over again in our organization or done over and over again by our stakeholders or customers that if it was done by a machine would free up the number of people required to do that? And it could be in terms of applying for something, getting something considered. It could be also just simply considering whether you approve some process or not, some algorithm like that. Those rote and repetitive sort of tasks are perfect for a machine learning task. Another area would be those things. What are those things that right now take a very long time to get done? And maybe there's many steps to them. And that's where I think, again, the security examples of if you have to do vulnerability scans and then other things on a checklist to decide whether or not you take on or approve a certain system, that would tend to lend itself to pairing humans with AI if you could get the approval process down from, say, 2 months to get a new system approved to being a few days or less. So it's either things that do rote repetitive actions or things that take a lot of time to get done and are very cumbersome. The last is those that require coordination across a lot of different people. And maybe you're in an organization that's very large and you've got different organizational stovepipes. The AI could actually sort of help with routing and tipping and queuing people to say, look, I know you're in marketing, I know you think you're only focusing on this area, but what you may not know is these people in this other business function over here are doing something that's related, and the two of you should work together. And I'm basing that off of either documents you're looking at, or I'm basing it off of web queries they've been doing, or just other functions. It's almost like the Amazon recommendation engine that says, employees that looked at the following sources of information, like you, were these employees, and if you're not connecting with them, you may want to connect with them. And so I think those are the 3 sort of general classes of problem where things can be better. The other only dimension I would add to that is those things that are outward facing to your customers and stakeholders. That's got to be careful because you're obviously going to be changing how you interact with them, and nobody wants an unpleasurable experience with a machine. So I'm not saying necessarily you rush to the customers first, but if you do engage them, maybe have focus groups as you build up to whatever you're going to roll out. Or those things that are on the back end that makes the back end better and much faster and responsive to the customer on the outside as well.
Yeah. So the first example that you gave makes me think of, I just saw an article like 1 or 2 weeks ago about Amazon, and that, where they used to have, buying teams of say 15 people to negotiate with, X number of vendors as to what they'll, what they want to pay, or, how many to stock and all that kind of things, that now they're down to one person and AI, machine learning. So one of those things which is, great for the organization, except if you're one of the other 14. But that definitely gets to the repetitive part. But I'm really curious about, and maybe concerned about the last part where the AI is sort of facilitating engagement across different groups. And that's, it's one, because like that's totally out of left field for me. I would never have thought that facilitation would be a problem that AI or machine learning would solve. But secondly, the concern comes from that in order to divine that, I should be talking to Fred over in marketing, means that, like, you're tracking all of my online activities in the organization, while I'm on my computer, what I'm browsing, what I'm reading, and so on and so forth. That seems a little bit, maybe not creepy, but
no, I understand. It sounds like surveillance in the workplace, but I'm with you there that it sounds uneasy. But let me pause and ask: you do realize that that's what apps on your phone are doing on a daily basis, right? Their goal is to get you to use the app as often as possible, and so they are going to optimize delivery of content or optimize whatever they're providing to you in a way that makes you want to reuse it over and over again, and they're monitoring what you're doing.
True, but depending on, I don't want to go down a total rabbit hole here, but depending on the app and the operating system, like there's things are sandboxed between one app and another, and unless you provide explicit rights to share data across those two,
right.
The second app doesn't have the benefit of knowledge in the way that you were speaking about it.
Right. So you're saying that you feel better because it's a little bit more compartmentalized, but I would caution and say, I mean, we've seen certain very large companies sell their data to, say, banking sectors, or sell their data across companies. And so you may think because the apps are separate and you have firewalled them in your phone, but I would say behind the scenes, there may be brokerage of data that you just don't know about. And so I would just test that assertion that there's a separation. But I do agree with you that it does sound like surveillance in the workplace, and that's a concern. I think part of that is where we need to start figuring out a model in the consumer space that can scale to the business place that says you decide when and where you share your data in the consumer space, and you have a locus of choice, as opposed to right now where the apps are basically siphoning it off and you really have no choice. I think workplaces of the future, unfortunately in the long run, those that don't figure out better ways to share data and improve how humans work together as teams, or what I like to call crews, KREWESs, and it's not a term I coined. Bruce Sterling gets credit for that. Those organizations that don't do that will fall behind, because you will be drowning in data. The talk that I like to give people as to why. So 2013, we made history. There was 7.1 billion human beings on the face of the planet and about 7.1 billion network devices. 2 years later, in 2015, there were about 7.3 billion human beings and 14 billion network devices. That's going to continue to grow, about doubling about every 2 years. So it's a variation on Moore's law. So that in just 4 years, in 2022, it's going to be anywhere between 75 and 300 billion network devices on the face of the planet, relative to 8 billion human beings. Obviously, they won't all be distributed across the planet equally. Some places will have more sensors than others. But it does raise questions about, can you actually go anywhere and not be observed in the future? The other thing, though, is the amount of data on the planet's doubling at least every 18 months. 2013 saw 4 billion terabytes, 4 zettabytes of data. By 2022, less than 4 years from now, we're talking about 96 billion terabytes of data on the planet, which, to put that in perspective, some say it's twice all the conversations we've ever had as a species. And so if that's the amount of data on the planet in just 4 years, I would submit trying to search by keyword those things that are important to your organization. Unless you go past the 5th or 6th or 7th pages of search results, you will miss things. You're going to have the machine tip and cue and suggest, hey, this might be useful to you. And you look at it and you're like, nah, it's not. So you don't use it, and you have passively taught the machine, don't bring me things like that. And maybe the machine comes back and says, I know you said this wasn't important, but did you see this one little feature over here? Maybe you were looking for, signs of violence or concern in a marketplace, and I showed you this photo and you didn't think that was a sign. But if you zoom in over here, here's a photo of someone carrying a gun. And you're like, oh, okay, actually that is important now. And so the machine is learning from you as to what things need to be brought to your attention and what things don't need to be brought to your attention. That to me is actually the future of not search, but of just how do you thrive and adapt to this digital tsunami of data that is very real and is happening right now already. It's why large organizations often miss things. That will definitely only get worse in the years ahead. But yes, I do think you need to have some sort of arrangement that you can actually trust what the machine's doing. And that's probably needs to be some sort of explicit, we almost need to have, each of us need to have our own personal digital assistant that works only for us, that is our broker to other assistants or other data streams out there, and says, are you willing to share your data for healthcare purposes? And you say no. Says, okay. Comes back later and says, if I detect that, you've been in a car accident, do you want to share your data? You might say yes or no. If I detect that your heart rate drops below 40 beats per minute, do you want to share health data? And you might have said no up until then, but if your heart rate drops that low, then maybe you're willing to do it. But it's got to be a natural language conversation, and it's got to put it into teams. Because getting back to human biases, there's a wonderful experiment where you can take teams that have worked together, they're well performing, they've done 10 years of working together, and you bring them together and you randomly give them red beads versus blue beads. And you tell them, hang out with each other for just 20 minutes. The red team over here, the blue team over here. At the end of 20 minutes, you come back and you say, okay, we're gonna play a game. I'm gonna give you each 20 bucks. You can bet some of it, none of it, or all of it. Whichever team collectively bets the most will get double their money. The other team won't get anything. It's just a tie, nobody gets anything at all. And you can watch these two teams that previously worked together as a single team convince themselves that they're going to be aggressive, more risk-taking than the other colored team, red versus blue. So of course, both teams bet everything and nobody gets anything. I submit that this often is the cause of silos in organizations. It's the moment you label something as this is marketing, or this is strategy, or this is customer engagement, we start to identify with those teams, and we have an us versus them phenomenon set up. AI doesn't do that. That's not something that we have it us versus them because of our evolutionary background. Machines don't have that. And so the machine can overcome that and say, yeah, I know you don't normally talk to those people over there because they're not part of your normal crowd, but we as an organization could actually do better if you did, and I'm going to suggest that you do.
I wonder if BattleBots probably have a little bit more of that us versus them, but that's
could be.
Yeah. So I want to kind of reflect off of kind of the next area I was going to go is to how to experiment and how to kind of get started with AI and riff off a little bit of what Matt Schultz from USA asked in terms of there's the technical aspect of how you maybe start to go forward, but then there's also that aspect of how do you if you do have a group of people who can build the algorithms and know how to use TensorFlow and Keras or whatever platform that you're using that they've chosen, how do you get them to work with the people on the business side in a way so that there's an understanding of, well, what is it that we're trying to really do and get to, so that as you run these experiments, we can be successful?
Right. And that's a great question. And thanks, Matt, for that. And I would say, I've always been a fan of saying there are no IT projects. There are business projects that have IT baked into them. I would say the same thing. There's no AI projects. There are business projects that have AI baked into it. And so you're absolutely right that oftentimes the business unit has problem articulating the problem or goal in a way that the AI team can understand. And part of it is if things are going well enough for the business unit, they don't really want to mess things up. It's again that it's crossing the chasm. If things are going well enough, why should we make a change? And also, they don't quite understand that technology is the art of the possible, and their goal is not to try and constrain the technology or be constrained by what's being done today, but to actually sort of explore the space that's new, that would actually be a competitive advantage relative to what anyone else is doing. So how to bridge that gap? I like to almost run as an internal venture capitalist when I do this inside of organizations. And I like to ask people to give me 3 reasons why we should do something, but also give me 3 reasons why we should not do it. And then how we're going to mitigate those 3 reasons why we should not do that. And so if you're having problems crossing the chasm between what the business unit think needs to be done and the machine learning or the modelers team, get them to collectively identify what are the 3 reasons why we should do this effort, and get both business to give their answers and the machine learning folks and see where there's a difference. And then what are 3 reasons why we should not do it? And the business unit might have different answers. In fact, I guarantee you will have different answers than the AI folks. But by doing that second and third order dive, you can then ask, okay, well, how are we going to mitigate those reasons why we should not do that effort? It makes it a little bit more like a VC pitch and a little bit more focused. I do also think it is about, as we talked a little bit earlier, a lot of the AI advantages is that you don't need as many people going forward. And you may find resistance in business units because they don't want to be outsourced, and that's completely understandable. And unless the head of the company says, look, if your job gets removed because AI is now doing it and we promise to retrain you, you may get people in organizations unfortunately sabotaging modernization efforts because they don't want to have their jobs replaced. And I've seen several examples. There's another example where I knew one organization that was manually trying to make sense of different forms they wanted to get brought in. And so they did the mechanical Turk model where they had the humans were doing that, but they had the machine watching it. And after about 2 years, the machine was able to do it without the humans. And so those humans weren't needed anymore. And so that's an understandable concern that does get to deep questions about the future of work and our social obligations there. But I do think trying to get the business unit to say why they think something needs to be done, but also why not, or what might be the reasons why they shouldn't do it, and getting the modelers and the machine learning folks to do it too, you'll get better outcomes if you do that approach.
Okay, thanks. Another question that I see from Elsie. Yeah, obviously you need good data. You need a lot of data. So data pipelining is often a challenge, but also a prerequisite to get started. So, any suggestions of what kind of steps organizations need to take to, from a data pipelining perspective to get started with AI?
Well, so I think the first is just begin to identify what data is valuable in your organization, and where is it stored, and who's the steward for it. And I mean, not the IT person, because the default, the organization will say it's the IT people are there. And it's like, nope. IT will help you do things with it, but it actually needs to be someone in the business unit that is aware of why is this data being collected, what's being done with it, what's the useful parts of it. And so once you've done that, then you can actually say, well, what's the limits of this data, or what's the quality of this data? What's preventing us from being able to use it across the organization for other purposes? Is it just the quality of the data, or are there legal reasons why, whatever it might be? But until you actually have that sort of approach to data governance, the transformative ability of AI to improve your entire organization will be limited. And I think that's going to be a key part. It also gets to the other question I saw someone ask about voice recognition. Why hasn't voice recognition improved? Well, I think it gets back to the reason why that initially language translation was having a problem, is that a lot of voice recognition was statistically based. And I think they're beginning to make the shifts now to just exposing enough data. And as folks probably know, every time you talk to Siri, by the way, is keeping a copy of that conversation. There are other apps that are doing that too. And so AI the third wave of AI has not really been applied to voice recognition yet. We're still applying the second wave, which is expert systems that are statistically based, Bayesian based, trying to guess the words you're saying based on statistically what you just said. 85% of the time is the word, I don't know, people, but it might be something else. And so once enough data is collected on voice, and this is again where I wonder, will countries that are, how best to put this, well, countries that are less appropriate in their protections of people's voice conversations have an unfortunate competitive advantage versus those that are, get better at voice recognition than those. It's just a big data problem. Once we have enough conversations, the machines will do it.
Yeah, and I think maybe back a little bit to Elsie's question around data. Just another thought I wanted to add is that another thing that organizations need to think about is data that they have that they don't think about as data that they have. And by that, I mean that there's a lot of apps, and I'll just take the insurance industry as an example. So, I someone rear ends me, and so I take a picture of that. Either the adjuster does or I do it via an app that they give me, and that becomes part of the claim. Mm-hmm. But now with machine learning, typically that was just an attachment that someone looked at, and essentially is like printing out taking a Polaroid and paper clipping it to the file. And it was something that we referenced, but we weren't actively using in any way. But now through machine learning and machine vision, we can, the machine can see those photos in a way that they were not able to before.
Right.
And so I would imagine that there's a part of, as you put together a data governance structure, really also uncovering those, kind of hidden data that we never used before. And then figuring out, well, then how could we use them going forward? Because, if we were evaluating the claim versus the photo and starting to see, well, if I see another photo that looks like this one where the car was totaled, I can start to make decisions about, maybe more quickly or more accurately about what the reimbursement needs to be or what the next steps need to be on that claim. But again, now you're looking at new data that you had that allows you to ask new questions or get new answers that you couldn't be previously.
Yes, and actually to add to that real quick, so in addition to some of the things I do, I work with a company that does geotemporal and geospatial analyses, a lot of which can involve machine learning. And it's amazing how many organizations have not thought about things that either link to time or space in the different data sets in their organization. And I think that's partly just because a lot of our databases, while folks are moving beyond just SQL transactions and things like that, that was ERP, that was SQL was all about the transaction, and then later figuring out how they link together in time and space. But now what's happening with a combination of AI and also just new ways of storing data, you can start every event that happened in this location or everything that happened within this window of time or both, and then you can sort out the transactions. And that's a complete shift in how organizations make sense of the data they have. And I think that's key, is think about how your data comes together to give you perspective of space and time events in your organization, and then the transactions as opposed to transactions first.
Okay. All right, we're starting to run close to the end of our time, and I want to respect everyone's time, including yours, David. But I do want to try and touch on one last thing, a little bit more on privacy and a little bit of ethics. So we talked about the triangulation a little bit, but one thing that you mentioned to me, which I thought was really interesting, I don't remember what you called it, but as we look at privacy and consent and not try and cross any lines as an organization, you talked about maybe needing some new roles in the organization to be like an ombudsman for these sorts of things.
Yeah, I'm a big supporter of this and would love to champion it more. And so again, this gets to the value of data, which is if the data is not diverse or representative, or if it's again the garbage in, garbage out principle, then you're going to get bad outcomes in the organization. And you may also have second or third order effects you never intended. I'll give a concrete example. There was one U.S. state that fed in about 30 years of jury decisions on setting bail, and unfortunately later realized that the jury decisions on setting bail were not necessarily as balanced as they should have been. And so fortunately they took steps and they stopped that effort because they realized that decisions that were made in the 60s maybe were not as egalitarian as they should have been. So you need to have this data ombuds function, I think, to protect your organization and also make sure that the decisions that are being made by any AI are accurate. And so they're looking at the representativeness of the data, they're looking at the diversity of data, but they're also, maybe they're involving outside members of the public, because the public's going to say, how can I know your company is doing the right things with my data? And so you involve them, you get them to say, look, you can't say specifically some of the secret sauce stuff we're doing, but you can bear witness to what we're doing is appropriate and right as an outside observer. And then also you need to make sure the machine reaches right correlations or decisions. I imagine folks on this call remember there used to be a thing called Google Flu Trends. It was done around 2011, 2012, which was using, when you go to Google and you type in a search term, such as, what's the treatment for flu, or how do I know I have flu, or things like that. Well, Google's just seeing enough data. It can actually predict when it thought the flu season was happening in different parts around the world based on the things that people were typing into the search engine. And it turned out for a while that was better than the Centers for Disease Control's methods of doing predicting of the flu season. And so for a while, people are like, this is the future. Let the search algorithms decide when the flu season's coming on and who needs this human activity. Well, it worked well for about a year and a half. And then Google predicted the flu season was going to occur in the summer in the United States, which is completely wrong. I mean, all of us know flu doesn't usually start until the fall, winter, when things start getting colder. And the machine was just off by at least 6 months. And they actually discontinued Google Flu Trends after that. And what had happened was it got over-specified on things that didn't matter in the keyword search. And that can happen with AI as well. If you tighten the strings too tightly, or if you over-specify on things, what was a optimization and well-tuned machine can end up just going completely wrong and going completely bonkers. And actually, there's some fun videos online that I would recommend people look at. One is if you go to YouTube and you do AI learns how to play asteroids. This is an example of a deep neural network that is just doing multiple iterations of the game with different random permeations. So there's one where the thing just sits there, well, that dies, and so that iteration doesn't move on to the next generation. But there's another one that moves around. Okay, that's better. Okay. There's another one that actually comes up with an interesting mutation, which it spins around lots and lots of times, which actually turns out to be a very interesting strategy. But it's worth watching what the machine does. But anyway, I raise that because this data ombuds function of humans could help have accountability in an organization to make sure that the right data is being used, that it's representative. But then two, circling back and saying, is this machine making what we think are accurate predictions that actually improve the business and not going to some place that we don't want to go to?
And part of that of not going where we want to go to is that, are you talking about just a financial health of the organization, or are you also looking at, hey, where this is leading us to make decisions that
right.
we don't want to make that are
right? Yeah, for example, it might say you should turn down loans from these types of people, and you're like, yeah, that's not right, that's discrimination or something like that. That would be something where it may have found a pattern, but you have to say that's not right for society. Same thing with medical decisions. It may find that there's certain people that are more likely to have a successful organ transplant, but if that's something that is either based on gender, race, or something else, ethically, I think we as a society would say that's not right or that's not fair. And so that's where you need to have the human step in and actually also weigh in and says, you may have found a pattern, but that's not the right pattern we want to have as a society. Because otherwise, then we truly are falling into society by algorithm. And that sounds like a very scary society to me.
Right. Maybe that's a place where we can also use differential privacy to kind of remove some of those, characteristics out of the analysis. In a way.
We hope so. I mean, I think it's a very noble goal to do differential privacy. I think we'll only know about 30 years from now whether it's truly possible to do it, or if with enough data, even if you remove that information, something else will give information away. And again, I mentioned like with DNA testing, you yourself may have kept your DNA completely private, but if other family members have done DNA tests, odds are they can triangulate who you are.
Okay. All right. I could keep talking really all afternoon, but I'm sure everyone, including yourself, have other things to do. And we're more or less at the end of time. So let me just ask kind of a wrap-up question. It's what's your prediction, kind of for the future, with AI? What should we be able to expect over the next 5 or 10 years? I mean, over the last 5 or 10, especially with the advent of the GPU to really enable us to do the processing in ways that we couldn't previously. We've made leaps and bounds. What do you think the next 5 or 10 years look like?
Sure. And by the way, I want to thank the entire audience. While I can't see all your faces, I really appreciate you taking the time to do this. And hopefully I've been coherent. I actually just got off a 26-hour flight from India, so I'm a little jet lagged, but really was excited to have this conversation. In terms of the next 5 to 10 years, I think we're going to see over the next 1 to 2 years serious questions about how do societies bring in these technologies. And some of them are going to be based on reality, but a lot are going to be based on hype or concerns, or concerns based on Hollywood, which is troubling. And so I think we need to have more of us in the technology space having these conversations, because we can bring some down-to-earth reasoning about what's real, what's not real, the limits of this capability. I think we're also going to find that we got to get some other things right before we can rush to AI, such as grooming your data, such as moving to cloud, such as improving processes. I mean, we didn't even talk, but one of the things I actually think organizations often forget to do is they don't improve their actual how they work processes before they rush to do AI. And they think technology is going to solve everything, when in fact, if you do a better designed process for how things work, you'll get leaps and bounds of gains as well. In terms of what's the next technology leap, I could imagine maybe around 2020, maybe 2021, if not earlier. I could see first we'll be a little disillusioned with AI didn't do everything we wanted it to, just like we were with the second wave and the first wave in the 50s and then the 80s. But I predict around 2025, if not sooner, we'll see some fourth wave of AI that, if I was to say what would be the thing that enables the fourth wave to be different than the third wave, it probably will be advances in quantum computing. And then you're no longer having to do things in series, that you can actually do things that massively parallel thanks to the weirdness of what quantum particles do. And so, recognizing that seems so far way off in 7 years, to me, it's exciting that we're even like talking about quantum computing, whereas I can remember thinking about this about 10 years ago and they said it's not going to happen until 2040 or beyond. But when that happens, so sort of the Van Neumann architecture, the run things in series architectures, even if you do parallel CPUs, will seem quaint. And we'll have to be able to do things, basically run things in multiple wave states and do things that we just could not even begin now. And I think when that happens, then you could actually imagine if you could run 100,000 simulations about the world in parallel in real time in less than a minute. Then you get to some very interesting questions where you can even ask the machine and say, run this over and over again about the world and select whichever model is best every minute and optimize to that. You could get to there's some interesting, maybe not artificial general intelligence, but some really interesting models about how the world works and predictive about human behavior and other behaviors on the planet.
Wow. That's pretty profound. And if nothing else, you've just imagined the perfect magic 8-ball.
Exactly. Shake it and say, maybe, maybe not, or that's just it. With quantum, if you observe it, then you've already sort of set it on a state. But again, I want to thank everyone for this. I think if I can make one quick plug real quick.
Yes, please.
Go to peoplecentered.net. We have an event on December 10th. It's going to have Tim Berners-Lee, Vint Cerf, Dame Wendy Hall, Steve Wozniak, several others. We'll live stream it on YouTube. But it basically is going to be what we're calling our people-centered digital future. And the goal is to have conversations on AI, but other topics as well, and to make sure that the future is much more of a digital renaissance versus a digital dark age for us all. So if you can join us either online or in person at the event, if you have questions, we welcome it. And again, I thank everyone for this.
All right. Thank you, David. And thanks everyone for joining us today. That was fabulous. And like I said, I could talk to David all day and, just keep learning from him. He's really brilliant. Beyond trying to sign up to, see the People-Centered Internet conference. Also, if anyone has an interest in participating in the ET Exchange conference in November that Maribel is chairing, please let me know, and we'll try and get you signed up for that too.
And thank you for tuning in to another episode of Device Squad, the podcast for the mobile enterprise from Propelics, and an Exec company.
Thanks, everyone, and we'll talk to you next month.